So this recording is about moles. So moles are a quantity, and we have learned how to do some conversions with moles. So we have learned how to convert from moles to mass, and to do that we use our molar mass. We have learned to convert between moles and particles, and to do that we use Avogadro's number. And then we have also learned to convert moles of substance A to moles of substance B using our mole ratio. So I am going to do an example of one-step conversion of each of these types. Remember, whenever you see the word mass or grams, that is your clue you need your molar mass. If you see particles, atoms, molecules, that is your clue that you need Avogadro's number. And if you have to convert between one substance to another, that is your clue that you're using your mole ratio. Okay, so here's the first example we're going to do. Calculate the number of grams present in 488 moles of calcium carbonate. So I like to start with my given. That's the number given to you in the problem, 488 moles of calcium carbonate. Then I figure out my unknown, what I'm solving for, grams of calcium carbonate. So again, your clue here is your grams. Anytime you see grams or mass, you are going to use molar mass. So we're going to need to calculate the molar mass of calcium carbonate, which you use the periodic table to figure that out. So we add the mass of one calcium plus the mass of one carbon plus the mass of 3 oxygens all together to get our molar mass. Then we set up our dimensional analysis. Always start your dimensional analysis with your given. And then you're going to draw your time sign and your fraction. The fraction we're going to use is our molar mass. Molar mass is grams over 1 mole. And the grams we get is from the periodic table. Remember, the unit that you are trying to cancel out is the one that's going to go at the bottom. The unit you're trying to solve for, grams, is going to go at the top. So I calculate my molar mass of calcium carbonate, which happens to be 100.086 grams of calcium carbonate per 1 mole of calcium carbonate. And then, because moles over moles cancels out, I'm going to be left with my units of grams, which is what I want. In the calculator, I plug in 488 times 100.086, and the calculator gives me my answer. I'm going to only use 3 significant figures. So this is my answer. Try it out. Now I'm going to do another example. Okay, so how many moles are equivalent to 9.96 times 10 to the 26 atoms of tellurium? Clue here, the word atoms. That tells us that we need Avogadro's number. All right, so we are going to start with our given, 9.96 times 10 to the 26 atoms of tellurium. Our unknown is our moles of tellurium. So again, because we have atoms, we need to use Avogadro's number. Set up your dimensional analysis with your given first, your multiplication sign, and your line. The unit you are trying to get rid of goes on the bottom. So this time, because we're getting rid of atoms, our Avogadro's number is going to go at the bottom. The unit that we want is moles. That's going to go at the top. All right, when we plug it into the calculator gives us, with significant figures, this answer. Try it out. Our very last example here, determine the moles of phosphate ion in the moles of calcium phosphate. So my given is my 5.216 moles of calcium phosphate. My unknown is my my unknown is my moles of phosphate. Moles of phosphate. Phosphate is PO4, 3 minus. All right, so because I am going from moles of one substance to moles of another substance, I'm converting from substance A to substance B, that is when I need my mole ratio. I am already in moles, so all I need is my mole ratio. Mole ratio can be used when you have units moles. So I set it up, 5.216 moles of calcium phosphate, and I'm going to convert it to just moles of phosphate. So my mole ratio comes from our subscripts right here. So in one calcium phosphate, we have 2 phosphate ions. So 2 moles of PO4, 3 minus, in 1 mole of the whole compound. We do our math. So we do 5.216 times 2 and get our answer, which is 10.43 moles of PO4, 3 minus. All right, that's it.